Okay. So like we did heating and cooling load calculation, and this is specified data and proposed data. Equipment also we have already selected. Now we can move to the air conditioning duct work, means designing and drafting we can do. So this is our RCP, reflected ceiling plan. And after the discussion with the architect and the possible location we have proposed, and these are the 8 terminals we are having. For example, within hot kitchen area, we are having square diffusers, 3 supply diffusers and 3 return diffusers are there. But the next size we have to select. And in the front areas, like serving area, we are having like linear slot diffusers only, 1 supply and 1 return. And side throw is there, side throw grill we have to propose there. And here we are not having any false ceiling, so we have to propose the air conditioning system here as well. Grill only we will be proposing, but the grill will be mounting on the duct side. Okay, so initially I'll be doing this hot kitchen. So already we did the heating and the cooling load calculation for this hot kitchen. Okay, let me select this is a RCP. No, let me select the RCP of this one. Okay, so this one I'll be making as RCP. So since we have not received, so I need to make this as an XREF. So close this one. Go there. Switch in this HVAC XREF. This one we can open. And this unnecessary things and all we can delete, and we can make this as an XREF. Okay, so at the time when we have did the heating and the cooling load calculation, we did this markings. Now we can remove that, and this one I'll be making it as an XREF. And also the base has to be corrected, so I'll be selecting this one. Okay, select it, and I'll be placing the base somewhere here. Okay, and just provide the base. Select that one. It is ready. If you're having doubt, you can see the base will be 0, 0, 0. Okay. No, this is 0, 0 only. But if you're having doubt, you can once again make it 0, 0, 0. This is already we have discussed in the project and drafting session before. And save this. So this is our XREF. Okay. Close it. Start a new project. Okay. I'm setting the unit. I'm starting now. Unit. Okay, decimal, precision 2 points I need, a millimeter only. Click OK. I don't want this grid. Okay, I'm attaching my XREF, XA ender, working HVAC, and this was my XREF. It is base corrected on only. Open it. No need to provide since the base point is already corrected. Click OK. You can see exactly it has located there. Okay. So initially I'll be doing the hot kitchen. Later I'll be moving to the server area and the dining area. See, the permissible location after the discussion, we can propose it when you are working within the company, and we can propose the machine location, but this one we have already discussed. When we are proposing the client and the remaining team is okay, we can proceed with that. But for this one, hot kitchen machine has to be proposed above this area. Serving area, this here we need 3 equipments. Now, first one we can propose here, and it is serving towards this side. And for this one, no, one machine has to be located somewhere here, another has to be located here. These are the location of machine. But initially, when we are proposing, sometimes the other teams are not like architecture or electrical team or client is having any objections, we can relocate it. But as per my suggestions, for this project, after the discussion, we have finalized this location. Based on this location of machine, we will be doing the routing. Initially, I'll be doing this one. Which one? Hot kitchen. Okay, I'll be placing the machine there. The machine block we have already created in the last session. Okay, so this is my XREF. And XREF, if you want to fade it, if you want to fade the XREF, you can do one thing. You can go to the layer property, and after that, the XREF, all the XREF layers you can select. And the XREF you can select together. Sorry. You can select together the color code 251, 252, or 253. You can provide accordingly. You can adjust. Anyhow, since in this RCP, the diffuser, everything we have already provided the color. I'm not changing it. Okay, the same color we can keep because it is already faded. And now I need to place my machine. Okay, before that, go to the layer property. I'm just creating a layer filter there. Okay, a group filter I'm creating. Let me name that as HVAC. Okay, within this HVAC, you can create a new layers, layer 1, layer 2, layer 3. therefore layer 5. Let me select it. So this one I'll be making as HVAC FCU. Okay, then HVAC SAD, HVAC thermal insulation, HVAC acoustic lining, then HVAC text I'll be providing now. So this text color, let me select this one. HVAC SAD color number for time being 180, color number 180 we can provide. Okay, and yeah, keep it there. Okay, I'm just selecting the HVAC SAD layer, make it as a current layer. Okay, make current, and I'm selecting a polyline, and after that through this supply, this is my supply diffuser, I'll be making a line there. Make sure the ortho has on, and because how I am proposing, I'm planning to propose, I will be placing my machine somewhere here. Okay, and then I'll be routing my duct. That duct will be going through this side. So, sorry, my machine duct will be going there. So exactly through the bottom of duct, I'll be making a drop, and that drop will be connecting to this diffuser. Diffuser next size has to be selected. Then my duct will be going here. Then I'll be providing. Anyhow, taking a route will be difficult. No, rigid connection will be difficult there. So here I'll be going for flexible duct and plenum box. As per the location, like that only we can do. So that's why to get the center point, no, because if you want to take a drop, no, you should get that center point. To get the center point, I made this. Somewhere there, I need to propose my machine. Okay. So trim this one, TR double enter, this one and this one. Okay. And I'll be placing, because I need to get the center point, no, to make the rigid drop. That's why I made the line through the diffuser. This is my center line. And I need to propose my machine now. This one, my fan coil unit. So we have already created the W block. You can go to the insert section. Okay, block from library. You can search it, no? Block from library, kitchen project, working, W block, this one. Open this. Okay, select it. Where it is, yeah, there. Close it. Now you need to place the machine somewhere there. Move it back. Enter. I'll be moving it back. So minimum distance from the wall, I need 300 mm to take the return. So enter from the wall at least 300 mm. If you are getting beyond 300, that will be fine. I'll be placing there. That's fine. Okay. And the TR double enter. Trim this one. This one. Delete. Okay. Move it there later. We can take it. And we need a flexible duct connector. So I'm just making a polyline there. Okay. And make sure this has located in HVAC FCU. The color will not change since it is a W block. If you want to do that, you have to explode it. Select it O under 50 mm. I am offsetting 50 mm. Then once again 50 mm. Now the flexible duct connector I need. So I'm taking a circle, 2-point circle here to here. Again 2-point circle here to here. Now just trim this one. And you can select it, mirror with respect to this point, we can mirror it to the other side. Okay, that is my flexible duct connector. Now the duct, few other things we have to select, no? Means we have to select the diffuser, then we have to size the duct, then only we can make it like a two-dimensional layout. I placed to my machine, I did the duct routing. Now duct sizing, before that air terminal has to be selected. See, we need to do the calculations for that. Okay, so for example, what's the space that we are having now? Okay, space is hot kitchen. Then the airflow rate, I need that in CFM. Then airflow rate, I need in liter per second as well. Then we need number NC value for that space. NC value in decibels. Okay. Delivery velocity in meter per second means through the terminal. Number of supply diffusers. Number of supply terminals. And CFM or airflow rate per terminal. In CFM we will be doing. Okay, then the diffuser, next size. Fine. Okay. The space is hot kitchen only. Control C, paste it. Control V, hot kitchen. Airflow rate, the selected proposed data. Airflow rate we are getting 1426 CFM. 1426 CFM. Airflow rate in liter per second is 1426 divided by 2.119. NC value, you can take it from ASHRAE fundamentals, no? Chapter number 48 of 2011. Sound and vibration, that chapter is there. Otherwise, almost all the air terminal manufacturers will be providing it. I am taking for the air terminal selection Airmaster as a reference. So if you are having Airmaster beta, which one your company or the client is following, that one you can select. So I am taking Airmaster as a reference. Page number 1 point, chapter number 1, page number 70. So 1.17, you can find it. Now I'll be selecting not hotel, kitchen area. Restaurants, cafeteria, lounges. No, if you are selecting like a cafeteria, or even if within the restaurant or the public kitchen and all, you can consider. Now, sound is not a criteria there. For the medium case, even if you are going up to like a 40 NC or 45 NC, that is fine. NC level, medium case you can select for design. We have already studied that in air terminal session in very elaborated way. Okay, anyhow, NC we need 40. I'm considering 40. Even if there is 45, that is fine. No need to consider 30 here, 30 for comfort spaces only. NC value 40. Delivery velocity, page number 1.7, you can select it. 3.5 will be optimum, but 1.7. Recommended delivery velocity for large offices, restaurants, computer cafeterias. No, this one. Either restaurants, hotel, dining rooms, no, even kitchen criteria we should get. It is not there, no, corridor, computer room, cafeteria, washroom, department stores. This is well fine. Even if you are going up to 6 meter per second, that is okay. Okay. So even if you are considering like a dining room, large offices, restaurants, this criteria also you can select. Maximum velocity you can go up to 5.5 meter per second. Optimum between 3.5 to 5.5. Okay. But you can go below 3.5, that is fine. Please don't go above 5.5 meter per second. Below 3.5 is permissible. Okay, anyhow, permissible velocity, delivery velocity like a 3.5 to 5.5 meter per second only. Between, if you are getting, you can go less than 3.5, no problem, but higher than 5.5 is not permissible. Number of supply terminal, no, as per the RCP, you can see 1, 2, 3 supply and 3 return, right? So number of supply terminals are 3. So the airflow rate per terminal in CFM, total airflow rate is 1426 divided by number of supply diffuser is 3. So we should deliver like a 475.3 CFM. Now we should select the next size. So I'll be going to the Airmaster catalog, and from there you can find a ceiling diffuser airflow data, 1 way, 2 way, 3 way. I need 4 way. 4 way. Okay, so per diffuser I need what? NC I can go up to 40. Delivery velocity even 3.5 to 5.5 is okay. Even if there is less than 3.5 is fine. 475 CFM. Okay, so like 475 CFM. Then NC 40. Delivery velocity 3.5 to 5.5. Even if that is less than 3.5, that is okay. But it should not go above 5.5. Okay, select it. Which one we can select? 150 next size not possible because 167 maximum we can deliver. 225 even if there is 375 CFM, is, you know, we have discussed already this one, that's why I'm not explaining everything. CFM is 375, NC is getting 41. Velocity is fine, But when you're going to the next one, 300, 300 is not possible, 225, 300, 300. 476 CFM, NC is getting 33 only. But we are having 475 only. So we can go up to NC 40 there. So this is okay. This is okay. And the net velocity is 2.5 only. We can go up to maximum 5.5. Between 3.5 to 5.5 is fine. Even if that is less than 3.5 is okay. So 2.5 is fine there. Optimum. So the next size we can select 300, 300. Okay. So 300, 300 should be the next size. That one we have to do. Okay. So the next size will be 300, 300. Okay. Now we can mark it. So the duct I'll be marking in liter per second only. So the airflow rate per terminal is like a 475.33. How much liter per second it is? That is 475.33 divided by 2.119. So each diffuser should have 224.3. I'll be rounding it. So this 224.3 we can consider as 224, or even if you are considering that as 225, it is fine. 225, it is fine. So because 225 into 3, final airflow rate you will be getting 675 CFM. So 3 liter per second, slight difference will come. 3 liter per second is nothing. Okay. So 225 liter per second, not CFM, liter per second. So let me go to the text option. Before that, like dimension style, modify. Okay, text and all, text height. Okay, let it be like a 3.5 or find some. We can check it on anyhow. Close it. And select the text. That is airflow rate. How much? 225 liter per second. So I'll be making it bold. Times New Roman is the font I am selecting. Okay, it is there. So this, go to the property. This one, the dimension style is standard only. Okay, so just go to the dim style. Standard, modify, text I'll be providing nearly 65. Okay, close it. Close it. And now you can select this one. Select it. This you can provide like 65. Okay, 225 liter per second. Fine. So keep it somewhere here. Amender. Use the command always, that will be good. But so this one will be like 225 liter per second. Okay. And this supply diffuser also should have 225 liter per second. This also should have 225. So in the starting branch and this branch, 3 branches. The starting branch I should have 225 into 3, 675 liter per second in the starting. 675 liter per second in the starting. So 675 minus 225. So 675 minus 225, I'll be having 450. Okay, so 450 here in this branch. 450 liter per second. Anyhow, this labeling and all we can adjust in the last. Finally, on this branch, we'll be having 225 liter per second. Anyhow, this air terminal, we are having 225. Air terminal labeling, everything we can do later. Okay. Anyhow, 675. This for this project, no? From the bottom of slab to the false ceiling, correct. For finished floor level to the false ceiling, we are having 2.7 meter. Bottom of slab, it is 3.9 meter now. So clearly, 1.2 meter of false ceiling height is available. So as you know, like if the false ceiling available is just like 1200 millimeter, hanging allowance 100, acoustic insulation 50, thermal insulation 50, bottom of duct to the false ceiling 100 mm. So overall, how much you will get? 300 mm. So even up to 900 mm height is permissible, right? With acoustic insulation allowances, 900 mm internal height is permissible since we are having no. So I will try to, this is 675 is less flow rate only. We don't want this 900 mm height and all. So maximum permissible duct height as per this false ceiling minus allowances 900 mm you can provide. We don't want that much. So I will try to make this one aspect ratio 1 if it is possible. Whenever it is possible, try to make it aspect ratio 1. So 675 liter per second, I am going to size it. And also try to maintain the velocity, starting branch velocity less than 6 meter per second for this mini equipment. In the duct sizing session we have discussed. I'm just going to the units metric. You can keep it same, no problem. 675 liter per second. Okay, 0.8 Pascal per meter. In 0.8 Pascal per meter, if I am not getting the proper velocity of 6 meter per second, if I am getting higher, then I will be decreasing it. 0.8 Pascal per meter velocity. I am getting 5.2 only, that is fine. And the equivalent diameter is 405. So try to make 450, 300. 400, 350 will be the right size. This is a clear internal dimension I required inside. So SAD, supplier duct, 675 liter per second. So starting branch, we need to consider acoustic lining. 400, 350, I'll be marking as 450. 300, no, for example. 400, 350, I'll be marking 450, 400. Correct. Here we need how much? 400, 350 only. But by acoustic lining, I have marked that as 400, 350. We have already studied that, right? So for clear, we need 400. This one I will delete later. Just for your knowledge, I am writing 400. 350 is the actual required, but we need the actual dimension of 450. Internal dimension, we need 400, 350. Actually, we will be constructing that into 450, 400. Okay. Let me make that 450 or under. 450 means 225 under here and 225 here. Mouth angle 45 maximum as per DW 144. So just shift at approximate distance of, let's say, 400, angle 315. Yeah, double under. Okay, you can mirror this one. MI under. Make sure ortho is turned on. And now you can mark it at TR double under. Okay, so the mouth is ready. And for this one, we should connect it. How? The starting 3 meter, I need to provide the acoustic lining. No, so 3 meter will come somewhere up to here. I need to provide acoustic lining. So up to here, I will not be decreasing the duct dimension. Anyhow, until here, it is not practically possible. Otherwise, in this branch also, I need to consider the acoustic lining. Let's see. Okay. Anyhow, now I need to connect this one. This one, no. Rigid connection will be difficult here. Rigid connection will be difficult because I can't take it like this. No, this will be difficult there. So we can go for instead of a rigid branch, we can go for a flexible duct. What might be the flexible duct diameter for 225 liter per second? So 225 liter per second from the table that I have given, you can take a 225 liter per second, 268 mm, 300 mm flexible duct we required. The diameter of flexible duct is 300 mm. Okay, and so 300 mm diffuser neck size is 300 only. Okay, but the plenum dimension we have to make it slightly bigger now. For example, the plenum size, because flexible duct with the plenum box we have to place. So this is my plenum box that will come above, and here I will be connecting the collar. From the duct side, it will be connecting to here. And the minimum width we need 300, plenum box 300. Height we required, since the flexible duct diameter is 300, to accommodate this collar now for hammering elements and all, 300 plus 25 plus 25, 350 mm height we required. In the project session, we have already studied this one. No? So 350 mm height we required. Okay, and also, as you can imagine, the flexible duct diameter is 300. So exactly as per the neck size, 300, if you are making your plenum box, then it will be difficult to accommodate this one. No? Correct. Because normally, square diffuser plenum box, already we have studied this one. That's why I'm not explaining much. Square diffuser plenum. Normally, the square diffuser plenum box will come exactly as per the dimension of neck only. But here it is not possible because Here we have to place this one, or which one? This collar. When you are placing this collar in the left side, right side, top side, bottom side, everywhere we need to do the hammering elements. Then only you can accommodate it. So for this one, since the flexible duct diameter is 300 mm, here 25, here 25. So the width of this plenum box we need 350, 350, correct. Then only we can accommodate. Otherwise 350, 300 will be fine, but this side also we can make it 300, 350. Okay, so the plenum box, see, even if the flexible duct diameter is less than 300, 25 mm allowances we have to provide extra, because inside the plenum boxes we need to provide acoustic lining. That acoustic lining allowance has to be provided. So always the plenum size should be 25 mm higher than the demand, then only we can accommodate it. Okay, so for anyhow, for my case, I need the plenum of 350, 350, height 350. Okay, so let me make the plenum box. Oh. Labeling everything we can do perfectly later. So the plenum box 350 mm into, or 350 into 350 into 350 mm. Which one is height? Height is 350 only. So flexible duct 300 dia, one number. The flow rate is 225 liter per second. We don't want multiple flexible duct, even single flexible duct will be fine, because you can see 225 liter per second normally for 3.9 meter per second. Flexible duct velocity, sometimes if you are keeping less than 2.5 meter per second, that will be fine. Less than 500 feet per minute, but this is kitchen only. Kitchen, we don't want that much. No, sound is not a big issue there. So less than 800 feet per minute or 4 meter per second is fine for flexible duct and all. In this case, it's a bigger flexible duct, 300. Okay, 268 we are getting, but when we are making into 300, still the velocity will decrease. Correct. It will come nearly 3 meter per second. It will not be 4. Exactly 260. After 250, we will be using 300 flex only. Correct. So that's why velocity is 3 only. That is totally fine. So let me make this plenum box now. 350, 350, 350, 350, and the collar I need to place there. So let me make a polyline, a reference line, and I'm making collar. So O under 50 mm under. The flexible duct diameter is 300. So O under 150 under, 150 here and 150 there. Okay, delete TR double enter. You can trim this one. Okay. Now this one you can delete. Place it there. Copy with respect to the midpoint. I'm not getting, no problem. Make a diagonal. Select it. CO enter. Okay. Place it exactly on the midpoint. That's a 300 flexible duct only. Now from the duct side. Okay. Now I need to make a flexible duct. Before that, somewhere here I'll be making a line. And this one, no, 300 dia flexible duct. So O ender, 300 means 150 mm ender, 150 there, and 150 here. And collar this distance I am making slightly 100 mm, because I need to provide around RVCD there. Okay. So correct. So this is coming like 300. So I need to make a 300 flex now. To make the 300 mm flexible duct, I am making 300 enter, 25 enter, 300 enter, even 25 enter. Okay. Now from here, I'll be making just 15 line, 15 mm. In the HVAC project session, we have already did these things before. Mirror, delete, delete. Select the spline. Make sure the ortho is off. 1, 2, 3, 4, 5. Enter. So copy the profile and place it there. Okay. So just do array, path array, select the path. Okay. Fine. This will be okay. Now we can take it, copy. You can place it here. This one you can adjust now. I will be adjusting. Okay. Make sure the flexible duct length is less than 1.5 meter, but it will come less than 1.5 meter only. Okay. So still, if you want to adjust slightly, you can move it back. Just anyhow, it should look like a flexible duct. That is fine. We don't want to make it like an extraordinary one. Yeah, this is fine. Okay. What's the length of this one? Select the line, LI, enter. That is coming like 1.2 meter. Correct. Here you can see the length is like 1.2 meter is getting. Length is 1.2. No problem. Overall, you can come up to maximum 1.5 meter. But this is horizontal length only, including the vertical. No, this is going horizontally, including the vertical. It will come nearly 1.5 meter. But still, if you want to decrease, you can move it. But the problem is from the machine mouth, we need like this is 789 mm. We are getting fine. Because from the machine mouth, 1 feet 6 inches, 450 mm gap should be there. After that only you have to connect the first flexible duct. So if you want to move it slightly back, you can do that. The next one, since after this collar, if you want to decrease the duct dimensions, you can do. But the problem, first 3 meter we have to introduce, we have to provide the acoustic lining. So this branch also you have to consider the acoustic lining. That's a problem. Okay. Anyhow, let me decrease it. I'll be decreasing this one. And fine. So let me enter 150, enter. So this I'll be deleting. Okay. And this branch, even though I am decreasing, starting 1 second, let me make a polyline where the 3 meter is coming. 3000, enter. It is coming here. Okay, up to here I need to maintain that duct. So better I can do one thing now. I can extend the same duct up to this diffuser. After that we can decrease it. So I'm not decreasing this duct dimension just for acoustic insulation elements. After this I will be decreasing it. Okay. Anyway, this diffuser, the next size is 300 only, 300. So let me make a polyline. So that is 300, enter. 300, enter. Diffuser neck 300, enter. 300, enter. So now you can, to represent the duct drop, you can make it like a 2 diagonal. Copy that one with respect to the center point. You can place it there. Okay. Now after this end of drop, we can extend this into like 150 mm. 150, because after the drop we need that hammering elements. Now you can, after this you can decrease it. Okay, from here we can decrease it, no problem. But you have to make sure that 225 liter per second, if you are planning to provide a duct drop, correct. Here anyhow, we are having a width of how much? We are having a width of 400. So since the diffuser, this diffuser next size is 300, duct is having a width of 400. From the bottom of duct 300 mm, collar, 300 mm rigid duct drop easily we can make. Means the duct width should be, if you want to take the rigid duct drop, the width of duct should be higher than 50 mm minimum, higher than the diffuser neck size, then only we can take it, right? And we have studied that. So that you have to make sure, because this duct neck size of this one is how much? 300 only. So this duct should have at least a width of 350, then only we can accommodate it. Otherwise, we have to go for flexible duct and cleaner box. So now I am sizing 225 liter per second, 225 liter per second. Let's say 0.8 Pascal per meter I'll be maintaining, because around 1.5 here, velocity is already less only. And duct, since the neck size is 300, width of duct I need minimum 350. So other side I am getting 175. 175 you can round into 200. 200. So 350, 200 is the duct dimension. So this one you can make SAD. Here acoustic lining is not mandatory, beyond 3 meter only. And this is 350, 200. Mark this one, no? Which one? Head loss and all. Later we can mark it, velocity also. Later you can do it at the time when you are doing the labeling. Now 350, 200 is the duct dimension. So final velocity will vary slightly. It will decrease only, no problem. Okay. Now you can make it like 350 means 175. So O enter, 175 enter, 175 here and 175 here. Okay. Here we need to propose an elbow. Also the duct dimensions has to be decreased there. Okay. And yeah, let me take it. Anyhow, from 450, the width has to be decreased into 350. So TR double ender. Double ender. Okay, fine. Now 350 means 175. So O ender, 175 enter. So this one and this one. I don't know whether we will get the taper distance there. After the taper, we need to propose an elbow as well there. So I'm taking O ender, let's say 150 mm. O ender, 150 ender. Just offset this one. And this taper angle I need less than 22.5 degree, right? See this one, it is not picking. Snap setting. Okay, object snap. So let me make a polyline. This one, this angle should be less than 22.5. We are getting 80 only, 18 only. So that is fine. How much? 15. TR double ender. 150 mm taper is fine there, since the angle is fine. Okay. So TR double ender. This one, you can delete it. Okay. Polyline. Because global width parameter has to be applied in most of the company. That's why I'm using polyline instead of line. Here double ender, this one and this one. Okay. Now here we need an elbow. Elbow short radius only, no? 350. So 100 mm is fine there. So F ender, R ender, 100 ender. It is not flattened. Two entities are non-coplanar, so that's why it has to be flattened. So FLA flatten ender. Select all these objects. Enter. N enter. Okay, save this one. Okay, so this is it's VAC. Save it. Okay. Fine. Now fillet radius. Enter. Now the lines are coplanar. Slightly explode it for time being. Later we can join. And the width of duct is like how much? 350. So O enter. Width is 350 enter. So we can offset this side. So trim this one and trim this one. Take a polyline and close this. Okay, fine. Instead of this elbow, we can do one thing. We can extend this duct up to here. From the duct side, we can propose a shoe collar. Through the collar also we can connect, but the pressure drop through the shoe collar will be slightly high. So that's why I'm not proposing it. And the next size we have already taken before selected. Copy Okay. Now after the drop, you can extend up to maximum 24, but 12 is fine. Means 12 inches means 300 mm. Sorry, you can extend up to maximum 12 inches, not 24. 12 inches, no, means like 300 mm, but 150 is fine. I'm going for 150 mm. Enter. Okay, so just fillet radius 0, you can apply. Now PR double enter, it is not extended, right? So EX TR double enter. Okay, yes. EX enter. Fine. TR double enter. Okay, fine. So I finished my duct work of this one. I don't want the middle line. I don't want the middle lines. So I need to propose a volume control damper there. VCD. Later we can propose it. And here I need to propose an RVCD as well. Okay. So take that is a round volume control damper only. Hatch it with respect to the bilayer. Okay. We can make it bigger later. Okay, that is my round volume control damper. Okay, so I did the duct work. First 3 meter we have to propose acoustic lining. So from the starting of machine to 3 meter. So enter. So up to here I need to provide acoustic lining. But the entire throughout the length if you are proposing, because only up to here if you are proposing the problem, until here, no, this 3 meter only, that is fine. But after that, no, actually the internal clear internal dimension we need 400 350 only. But only up to here if you are providing means no, the well, it will be affecting the velocity. So even if anyhow the ducted dimension we are not decreasing. So if you are providing here or if you are extending this one, no, means acoustic lining up to here, that will be fine. Otherwise, no. After this one, the area will be slightly increasing. No, actually we need 400 350. It will be slightly increasing. But one thing, 400 350 we need up to here only. Up to here, but after that we are not decreasing. Why it is? We are not decreasing because the internal dimension we need to accommodate no acoustic lining, so that's why. So it's not a big issue, so I'll be providing up to here only. So make it acoustic lining layer has to be taken. Acoustic lining color I'll be selecting, say 140. Okay, positive. Acoustic lining, make it current layer, select a polyline. I'll be selecting up to here, then from here, then I'm going there, then I'll be going here, then up to here, then I can go here. Okay. Even though internal dimension is decreasing until this point, it is not a big issue because this 450, 400 or 400, 350 dimension we need up to here only. But after this airflow rate, the duct dimension should decrease, but I have not decreased because the problem is like if I'm decreasing means I need to decrease until here, then to take this one will be difficult. Now, there also I need to consider which one acoustic lining. So better you can provide there, no, because actually we don't want 400 350 there, and this diffuser is located very near only. It is not a huge issue there. Or even if we are extending up to here, that is totally fine, no problem. Up to this distance, if you are extending, totally fine, no problem. It's not a huge issue. Okay, now we can provide the acoustic lining. Go to hatch option. It is like a cross. We can select. Select option. Select it. Okay, so this one I'll be providing. Let's see, 150 or no, that is very high. So even that is also 40. Okay, fine, that is too high. 5. Yeah. So once acoustic lining has done, you can delete it. Okay. So move it. Now, it's not finished. I have to do the labeling. Volume control damper has to be proposed to somewhere. Perfect labeling, plenum dimension, everything we have to mark in between. Okay, anyhow, the duct work I have finished there. This is called a designing and drafting. When you're making simply this drawing is called a drafting, because when you're doing the heating and the cooling load calculation, and after that, when you're selecting the equipment, then you'll be selecting the terminal, you're doing the duct dimension, you're sizing the flexible duct, you're sizing the plenum. All these things are called designing with the drafting. So later we will be moving to, in the next session we are having now. There we are having like this one, linear type diffusers, grill we have to propose, open area, no? There we are having like a return grill is there, no? So that we can do in the next session. Okay.